Okay, it's been a really busy weekend and it's late on a Sunday night, so I'm going to make this as quick as possible, but bear with me. Here goes nothing. We're going to talk about Venn diagrams tonight. Tonight we're going to talk about Venn diagrams. A Venn diagram is a rectangle, and the rectangle represents the sample space, and the circles represent certain events in our sample space. This Venn diagram could easily represent rolling a dice because we have the numbers 1 through 6 in it. That's my sample space. And event A in that case would represent rolling a 1 or a 2. And Venn diagrams are really helpful in solving some kinds of probability problems. Not all kinds, but some of them. A Venn diagram is a rectangle. Hopefully you had these in geometry. Not sure though. The rectangle, if we're talking about probability, represents the sample space, and circles in the Venn diagram are representative of events in our sample space. So here I have a sample space of 1 through 6, and in the circle I have 1 and 2. That would represent rolling a dice. And the event A would be the probability of rolling a 1 or it'd be the event rolling a 1 or a 2. In that case, then A naught would equal 3, 4, 5, and 6. And you'll notice that the probability of A plus the probability of A naught is equal to 1. Because the probability of A, event A, is equal to 2 out of 6, and the probability of the complement of A is equal to the 4 out of 6, and when I add these together, I get 1. You'll also notice that when I list the sample space, it is in set notation. It has set brackets. If I were to write this, you've seen this before, by the way, the symbol element. This reads as X is in A, or X is an element of A. All right, let's talk about unions and intersections. A union B, and the way I remember this is the union sign looks like a U. That is the union of sets A and B. If I were to write that out with set notation, don't flip your lid. That would be A union B is equal to X such that X is an element in A, or X is an element of B. That would represent the union of the sets. If I were to show this on a Venn diagram, I'd need to shade in set A, and then I'd need to shade in set B. And that's what A union B would look like. Both circles would be shaded in completely. Let's talk about intersection. So this is OR. Now we're going to talk about the intersection of two sets. In set notation, that looks like this. X such that X is an element of A and X is an element of B. This one is and, this one is or. So to be an element of both A and B, the only place that happens is here. Another symbol you should know about is this, N of A. Well, that reads as the number of elements in set A. Okay, ready to move on. Disjoint sets. I have two circles. You'll notice that they don't overlap anywhere. So A and B is the empty set. A and B are said to be mutually exclusive. This is called a mutually exclusive. It'll come up later again, so keep it in your notes. All right, my first example is if A is the set of all the factors of 36 and B is the set of all factors of 54, find A union B and for part 1, and part 2 is A intersect B. Well, first I need to figure out what's in A. A is all of the factors of 36, and those are 1, 2, 3, 4, 5 is not, 6, 9 is next, 12, 18, and 36. I think I got them all. Set B is all the factors of 54. Oh boy. Okay. 1, 2, 3, 6, 9, 18, 27, 54. Hopefully I got them all, but if I didn't, you'll get the right idea anyways. So I'm going to find the set of all. Let's see. The ones that, if I join both sets, then that's going to be 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, and 54. Okay, A and B is going to be, let's see, 1, 2, 3, 6, 9, and 18. If I draw a Venn diagram to represent this, I have in my overlapping part 1, 2, 3, 6, 9, and 18. Out here in my set A, I would have 4, 12, and 36, and in set B, I would have 27 and 54. And that should do it. All right, here's one for you. If the moment you've been waiting for, one for you to try. So I have this Venn diagram over here, and it represents a sample space S of all the children in a class. Each dot represents a student, and the event A shows all the students who have blue eyes. Determine the probability that a randomly selected child has blue eyes, and B, that they do not have blue eyes. Pause this, and when you're ready to check, restart it. Okay, so hopefully you counted all the little dots, and you could see that there were 8 students who have blue eyes, and out here I had 15 who do not have blue eyes. So in order to calculate the probability that they have blue eyes is the number of students with blue eyes, which was 8. That's here. Divided by the total number of students. So you needed to add the 15 and the 8 together because there are 23 students all totaled. So that's how you get 8 out of 23. And then the probability of not having blue eyes well, that's the students who do not have blue eyes over the total. So that's 15 out of the 23. Sometimes it's easier, remember, to calculate the complement instead. So you could have done 1 minus 8 over 23, which also would give you 15 out of 23. Here's another one to try. Give this a shot. This is the number of people in a sporting club who play tennis and hockey, and then you need to figure out how many there are of each of these categories. This is not a probability, you're just calculating the number of people. So you should have a number like 7 or 12 or whatever, but you're not calculating a probability here. So pause this and restart it when you're ready to check your answer.